Hello viewers, welcome to Timas TV. Today we are looking at example on transmission line. In this example, we are given that frequency is 50 Hz. We have the length of the line is 362 kilometers. We have the load. The load is 125 megawatts, and line voltage is 200 kilovolt. We also have that the power factor is unity, and we're asked to look for the line voltage at the sending and from the incident and the reflected voltage. And we're also further asked to compute the wavelength and the velocity of propagations. We are going to be doing that using these parameters, the line parameters given. This is your resistance, inductance, capacitance, and conductance. So first and foremost, we look at a series impedance. Series impedance is actually the combination of the resistance, that is resistance and inductance. So we have that from what we are given, 0.106 plus we have this is frequency is 50. We have this was millihenry, so we introduced that. So if you use a calculator, you are going to be having 0.16. Multiplying this one with your calculator, you arrive at 0.4257, and you have ohms per kilometers. So you can change this to polar form, and it's going to give you 0.439. The angle is 76 degree. So this is the series impedance per length of this line. The next one we are looking at is shunt admittance. We have the combination of the capacitance and conductance. So I'm going to be having this. So at this point we can realize that J was 0, and we have this 2 pi, multiply this with the frequency, and we multiply this 5 days. This will be 10 raised to the power of -9. So at this case we use calculator, and we're given that the shunt admittance is giving us 2.655. Multiply this with 10 raised to the power of -6, and the angle is 90 days. Please will confirm all this using your own calculator. So the next important parameter which we need to look at is propagation constant. Propagation constant is the next parameter that we are going to look at. So let's delete this. So at this point we also want to look at propagation constant. We multiply this with the actual length of the line. So, and we have that this is square root of series impedance and shunt admittance, and also multiply with the length. So this will give us 362 multiply with, so we put on the formula for the values, and this was 2.655 times 10 raised power of 6, multiply same with 0.439. So since it is multiplication, we are going to add two angles and divide by 2. So by doing that, you use your calculator, you're going to have in polar form 0.391, and this, the angle is 83 degrees. So we can express this as 0.0477 plus 0.3881. So we'll see how we can represent this with alpha L. The L is the length, and beta L. So from this, alpha L is 0 point this, and beta L is 0.3881. We've gotten that. So the next one is characteristics impedance. Characteristic impedance is actually y divided by the, that is this series impedance divided by shunt admittance, and doing this we have square root of 439, divide this by 2.655, than this, and the angle is going to be 96 minus 90 degree divided by 2. Is minus because the two parameters are divided. So at this point we have that ZC is 406.6 and the angle is minus 7. So that will help us. Another parameters we need to solve is VR. VR is the output terminal voltage, and this is gotten from the question. We have the line voltage to be 200. We divide this by root 3, and we have 115.5. The angle is 0, but is kilovolt. This is to neutral, this line to phase voltage. So the next that we need is IR. IR we have gotten from the load, which is 125 megawatts. You divide it by line voltage times root 3, and IR is giving us 361, and the angle is 0 amps. So these are the parameters we have gathered to make sure that we've gotten what we are actually looking for. So at this point we want to consider the voltage from the sending end and the receiving end. So we start with VR plus, that is the incident voltage at the sending end. We have this VR plus this ZC. since it's the receiving end, and z is x is 0 at that point. So what we do is that we just put in the parameters that we have gathered so far. VR is 111 115. This angle is 0. We also have that the IR is 361, angle is 02, and ZC 406 406.6, and angle is this. So if you are using your calculator to have all that, you are going to be having 13. This is giving you as 13.5, this minus 944. So you can put this in a polar form, and that will give us 13880, and the angle is minus 3.9 volts. So we also look at VR minus the reflected at the receiving end. So this is from a previous video. We took time to get all this information. So this is this. We have to plug in the parameters. So this will give us 11, this minus 361 multiply with this 7 this. So if we use our calculator, we are going to have minus 15,094 plus 8944. I am putting that in polar form. This is giving us 175.44. We have this is 194.6 and voltage. So that is the value of the incident and reflected at the receiving end. So let's look at what really happened at the sending end. At the sending end, we have that sending end, whether this is equals to 1. So quoting the formula that we are used to, we have that at the sending end, this is going to be half, that is going to be VR plus IR, this, and you realize that exponential this, exponential this. This is because x is not 0 when we have at the receiving end. So we are going to plug in the values that we've got. So this will give us putting in the values. We are going to have, we have gotten this before, and which is this. So this will also multiply this and this. So at that point, we are going to say this 880 3.9 multiply with exponential 0.047. This was gotten from propagation constant, we had previously and multiply this with the beta. This is 0.388. So having done that, you can use your calculator to confirm this. We are going to have 133.13088. Please, this is 0. The angle is still this. Multiply with 1.049. Multiply with the angle. The angle is 22.2 degrees. So I'm using your calculator. We are going to have the value for that. We have that this becomes 137 157. This is the angle and that's the voltage. So that is the incident at the sending end. So let's also look at the reflected. This is reflected at the sending end. So it's the same formula, it's just the sign will change. This is given off this minus this exponential. It's going to be minus. We have this exponential, this minus. So at this point, we've gotten this before. So we just introduced the value and it was 1754444 and the angle was 194.6 degree. So we multiply this with this was 0.0477. Also multiply with the beta. That beta times length is 0.3881. So when you use your calculator, you are going to realize that Vs minus is giving you 144 and this multiplying with 1 divided by 1.0 this and the angle is going to be this. So this is taken in the place of indices. So finally at this point we're going to have the answer to be 168 and the angle is 127.4. So we have gotten the value for the sending end and we also gotten value for the receiving end as was required the questions. So at this point the actual sending end, we are adding MV we're adding this plus this, so that will give us 13715. We have this. If you add it with the reflected value as sending end, please this was this plus take note We add it with this 16,840 this and 247. So the actual sending end value is 13. Sending value is 1326. We have the angle to be 25.2 volt. So that is the sending end value. So we also have to look at the line at the sending end. So we have line value to give us this 3. You multiply this with 3 with the sending end, and you're having root 3 times 132, that is in kilovolt. So we are going to have 2 and 3 kilovolt as your answer. And we also compute the wavelength and also the velocity. So at this point we can recall the propagation constants. So we realize that B is going to be 0.388 divided by the length. You know, this value was multiplied by 360 that was given. So at this point we are looking at the actual B. So you divide this with the length. You have using your calculator, you're going to have 1.6721 of minus 3. So, and you have this to be radian per this. And also lambda is going to be 2 pi divided by this guy, beta that we've gotten. And if you introduce, you have 58660. You have this in kilometer. So hence you can combine the velocity. The velocity is this from the wave concept. So we have the frequency is 50, and we multiply with lambda 55860. So velocity of propagation is actually 2.93 times 10 raised to power of 5 kilometer per second. Please, anywhere you're confused, you will need to go back to my former video on transmission line. That is when you have all the relationship that we've used in this example. So having listened to that example, I want my viewers to try their hands on this assignment. That the parameters of the transmission line is given as this. This one, the length is 350. The load is 180 megawatts at 22 kilovolt. Power factor is 100%. 0.11 ohms per kilometer is the resistance, and 1.23 millihenry per kilometer is inductance. Constant is this. Conductance is actually 0. So from this parameters, I want you to find the line voltage at the receiving end, and also compute the wavelength and velocity of propagation. Please write the answer in the comment section.